In this video, we'll be looking at another example of linear and angular speed. Our formulas that we can use, linear speed is equal to arc length divided by time. Linear speed is equal to the radius of the circle times the measure of the central angle in radians divided by time. Our linear speed is equal to the radius of the circle times the angular speed, or angular speed is equal to the measure of the central angle in radians divided by time. The example that we'll be doing, a satellite traveling in a circular orbit approximately 1,800 kilometers above the surface of the Earth takes 2.5 hours to make an orbit. Approximate the linear speed of the satellite in kilometers per hour. Now, a diagram of our problem. We have the Earth with a radius of 6,400 kilometers, and then the dotted line represents the orbit of the satellite. Notice that it is at an altitude of 1,800 kilometers above the surface of the Earth. So the radius of our satellite's orbit will be the radius of the Earth plus the 1,800 kilometers. So approximately 8,200 kilometers. We know that one orbit is the same as 2 pi radians. So we can use the formula linear speed is equal to the radius of the circle multiplied by the measure of the central angle in radians divided by time. We'll need the radius of the satellite's orbit, which is 8,200 kilometers, which we calculated right here. We're doing one orbit, which is 2 pi radians, and then the time is 2.5 hours. When we do the math on this one, we get 6,560 pi kilometers per hour. The next part of the problem, we want to approximate the distance that the satellite travels in 3.5 hours. Since we know that the satellite travels 6,560 pi kilometers in 1 hour, we can just multiply by 3.5 to get a total distance of 22,960 times pi kilometers.